plane has an anti-radiation missile, they'll shoot the missile back down towards the direction where the surface-to-air missile came from and knock the radar out. Basically, because that surface-to-air missile has to shoot down the plane, it needs a radar. If you can knock the radar out, you basically knock him out. This is the same approach that we're taking. We're homing in on the emissions of the wireless card, okay, of this 802.11 wireless card. Now, at present, or at least prior to this year, there was no tool that was actually specifically designed for the job of hunting users. Now, there were some commercial solutions, all right? Like, for example, you'd have various vendors who would position access points as sort of like sensors in a giant sensor net. But the problem with that is it's static. What happens if the guy is outside of your sensor net? You can't triangulate what's outside of your sensor net. Therefore, you have to be mobile. Okay? And of course, you could try to use a tool like AeroDump. If you look at the latest versions of AeroDump, basically the bottom part that actually has the a client connection with the BSSID or the access points, you could attempt to use AeroDump to actually track it down, but that would be a suboptimal solution. Okay? And you also have other vendors who basically tout iPACs or some other PDAs with wireless cards and omnidirectional antennas. The only problem with that is omnidirectional antennas are by their very nature designed to receive everything equally, all right, from all directions. It's not directional. It doesn't actually help you determine what signal is coming from what direction, okay? So in this case, the so-called RF donut, i.e. that pattern of RF receptivity and emissions, it may get flatter if it's high gain, you know, omnidirectional, but it is still a donut, all right? What you really need is some solution which is, number one, free, from the point of view of software, and which can use existing equipment, such as your laptop, your wireless card, or any other directional antenna that you have out there. So this leads us to the point of the presentation today, Moocher Hunter. Now, we've released Moocher Hunter earlier this year, but it was to a closed-door session of the Singapore police. So you guys are actually the first people outside of that closed-door session to actually get this in public, okay? It's dedicated tracking software that helps you hunt down anyone who is using a wireless network. It could be a legitimate user. It could be a moocher, all right? It doesn't matter. As long as he has a MAC address, a station address, and he's using your access point to send data across, basically Moocher Hunter would enable you to hunt down his physical location. Now, Moocher Hunter doesn't just rely on just pure data frames. It also correlates various other frames, for example, management frames and even control frames coming from the particular attacker. And as we all know, if you're doing any kind of 802.11 communications, you need control and you need management frames. So those also help you hunt the guy down. And best of all, obviously, it's free. Okay, we don't charge for Moocher Hunter. It's available as part of the free auditing toolkit that you can download from that URL up there. Okay, unfortunately, for some of the people who were asking us whether we intend to provide it as a standalone tool, it's basically bundled in as a tool with the toolkit. Now, the reason for that is because it's actually more efficient for us to actually maintain the tool that way. Okay, so based on what I've mentioned, all right, you have the tool, you have the sprint and drift technique, and you need to have some relevant hardware. And that relevant hardware basically is just the last link in the chain. Now, Moocher Hunter itself, the software, has an interface which is run on what we call ncurses, okay? And it's basically running off of your laptop. You look at the screen and it gives you directional weighted cues as to where the attacker is depending on where you're pointing your antenna. All right. Now, these directional weighted cues, which I'll show you when we get to the demo, basically allow you to gather quite a little bit of information with regards to how you would determine whether it's a reflected signal or whether it's really coming true from a particular direction or whether you're just actually going away from that particular guy. Okay. Now, this is a shot of the actual hardware. Obviously, that ain't me in the picture. That's my associate, Chris. You can see that he's using a directional antenna, much like this guy over here, all right? And he's actually got it connected to a wireless card, PCMCIe card, that's connected to his laptop. Now, you can get any of these from eBay, or if you're feeling adventurous enough, we have a presentation on our website that you can download called How to Build Your Own Cantenna. You can make your own external antenna and then basically connect it to your wireless card, okay? So you need all those things. You need the hardware, you need the tool, you need the technique. And pretty much with any kind of ingenuity, you can get all of them on the cheap. All right. So at this point, what I'm going to do is I am going to show you the interface of Moocher Hunter. I'm going to show you Moocher Hunter in action. And if we got time to spare, I'll give you an actual video of field trials that we actually did so you can see the technique in action. Okay? So give me a moment here while I bring up my console. Okay, as you can see here, is this big enough for everyone? Can everyone see, or do I have to make the font bigger? Everyone all right? Okay, I see lots of nods. Okay, that's good. So what we have here is Moocher Hunter, the binary. Oops. Oh, that is too big. Yeah, all right. Let me just get that a little bit smaller because that needs to be displayed in format that you can see. All right, there we go. So Moocher Hunter basically has a few flags, which are denoted over here, okay? There's an interface flag, all right, which basically tells your machine what interface you want to use Moocher Hunter on, because obviously only one of your cards may have an external antenna jack. The chipset flag over there is absolutely required. And the reason for that is because different wireless cards actually have slightly different ways of handling certain readings when it comes to actually assigning those readings and presenting it to you on the interface. So depending on the type of card chipset that you have, you're actually going to have to select from Atheros, Prism 54G, and so on. Okay, so you actually have to know what chipset is inside your card. For those of you who are more familiar with the branding, i.e. Netgear, D-Link, and so on, you can actually find a list of chipsets and what models they fall under which cards on our website. I'll give you the link at the very end of my presentation. Okay. There's also another flag called -T, right, which basically specifies the BSSID of the AP which you want to start doing your track on. Now, the reason for that is because you may not know the Moocher's MAC address to begin with. What you want to see is you want to see how many people are actually connected to your access point. Whether they are legit users, whether they are Moochers, we don't know at this point. So what we do know is that you, as let's say the owner of the access point, running the access point, you would know your BSSID, you know your access point's MAC address. So you essentially put it inside here, and then from there you'll see who's associated with it. We have another flag, right? This is basically the what we call the active track version called -M. This is, let's say, for example, if you halfway doing your track, you notice that, wait a minute, this guy is not there anymore. Maybe he moved to a new access point. Instead of doing a -T, you now know his MAC address that you're trying to track, and you can assign -M, and then you actually track him, and you don't need to know which new access point that he's connected to. Okay? So we have some notes below to basically tell you what to do in the case of some of your wireless cards going down and whatnot, because we find that, especially with things like the Atheros Mad Wi-Fi NG drivers, they are very, very twitchy. Okay, so what I'm going to do now is I'm just going to make sure my card is in what we call monitor mode. All right, this is not strictly necessary, but I like to be safe rather than sorry. So let me just check. Nope. Okay, mode monitor. All right, so let me just do that again. All right, so you can see the difference. You saw the mode from manage change to monitor now. So what we're going to do is we're going to run Moocher Hunter. Let me just go up. Okay. At this particular point, I actually have an access point, and the access point's BSSID is located here. Okay, I've just keyed this in. You can see based on the flags that I mentioned, there's an interface. Because my wireless card is, my interface is designated ETH2, and it's a Prism 54G chipset. So I'm just going to hit enter on that. And you can see it's pretty fast. Why? Because it detected the access point fairly quickly. As you can see over here, the access point is actually dead smack in the center of your screen. Very easy. And the clients actually all radiate around it. Right now, I only have one client because this particular access point is obviously my demo one, unless someone else wants to hook on and basically I can start tracking them down. But this particular client appears to be connected. Okay, so what we do is before we do that, I just want to show you the help screen. All right, by pressing Shift-H, you can get a help screen which basically tells you everything you need to know about navigation and how to use the Moocher Hunter tool from the screen. Okay, so as you can see, it's pretty comprehensive. What I'm going to do is I'm actually going to show you the actual track, the actual tracking screen. So let me just hit the escape key. Now, unfortunately, we only have one. Oh, okay. Great, now we have 2 because someone else has apparently tried to connect on. Now, if I run my arrow keys up and down, I basically can swap between the 2. So whoever you are, thank you very much. You just helped me at least make my presentation a little bit easier. And your arrow keys, the up and down arrow keys are the ones that select between the different clients that you have over there. Now, as this screen fills up, it fills up in a clockwise manner, so you can get a total of 9 clients that are connected here displayed. Once it goes beyond 9 clients, it goes to page 2. Okay, well, someone else is, is helping me do that. Let's see how many others we can get. But basically, once you get beyond 9 clients, your left and right arrow keys will basically swap between different pages. So as many clients as are connected over here, you basically have the ability to swap between the different pages to see, whether there's any client that actually is not meant to be there. Because I would imagine that as a knowledgeable user who's using a Moocher Hunter in an enterprise environment, you would have a list of who is allowed to connect, what MAC addresses are actually you actually bought with regards to wireless cards and issued to your staff. So you would be able to identify using your whitelist. So I'm just going to hit the enter key because you can see it's highlighted on the very first guy. Okay? And what you can see here is the tracking display. Now the tracking display basically tells you that you're focusing on this one guy. And as frames are being received by your wireless card, each frame is assigned particular characteristics or particular readings based on your hardware. It's not based on the software, it's based on your hardware. So every hardware, let's say whether you've got a Netgear WG511, whether you've got an Atheros-based card, will basically assign its own readings. But you don't have to worry that the readings are like incompatible between cards, because for the duration of the track that you are doing right now, your card, the one that you currently have stuck inside the laptop, is the one that matters. So relative to him, everybody else is ranked. Okay, so let's say if you have a frame coming in that is very much weaker, this power value over here will actually fluctuate and will actually read at a lower rating based on what your card received. Okay, so as you can see, it's changing fairly often because every time you receive a frame, that reading will change. And you can see below that there's a max and a min. The max is basically a historical reading of the highest powered frame that you received, and the minimum is the lowest powered frame that you received. So it's basically values assigned by your card. This actually helps you because if you're pointing in a particular direction, say for example you're going like that, okay? And the power reading that you see at the very top, if it drops below 41, it will assign a new low. So you know that you're not going in the right direction, all right? So you point somewhere else, you basically would get the reading getting higher. You can see just now, the reading was down at about mid-50s, high 50s. And if I point somewhere over there, you can see that the reading is going a little bit higher. It's going to about 76-ish, okay? Now, obviously, as it tends towards the higher, the maximum figure, it means that you're pretty much pointed in the right direction. So what you need to be doing is you need to be moving towards that direction. Okay? Now there are 3 more little components or figures over here. They're called CMD. Anyone want to guess what these stand for? C, M, and D. Exactly. Control, management, and data frames. Now, as you can see here, we're getting a fair stream of data. So this guy is definitely, not only is he associated, he's also probably doing web surfing or whatnot, okay? And you can see some management frames. Now, you might not get any control frames or management frames. That's okay, because typically what we find is that the further you are away from the guy, the less likely you are to get the control frames and management frames. This is essentially a very interesting observation in actual practice, because theoretically, the IEEE spec says that before you can even send a data frame, you've got to make sure that your CTS and RTS is already all cleared. And those are control frames. So by rights, we should be seeing more. But in any case, it doesn't really matter because we can already see from the management and the data frames. And you can see the very last line over there. It says last 10 seconds, all right? This is the total number of frames that you have received, right, in the last 10 seconds, regardless of whether it's data frames, management frames, or control frames. So this pretty much tells you his activity level. If the last 10 seconds is pretty low, that means he's either taking a lull or his machine is offline and you're basically not getting anything. But of course, if you're getting something like that, then it is obviously something very interesting, okay? In essence, that he's pretty much active on your network. So what I'm going to do is I'm just going to point this around, all right? And we're going to try to identify. Maybe what you guys can do is to help me identify and tell me when to stop moving